All right, welcome to our first webinar of 2022. My name is Haley Ralston, and I serve as the Alumni Relations Coordinator for Computer Science. Thank you all for joining us this evening to hear Doug Bowman and Sang-Won Lee share about the human-computer interaction research that students and professors are currently working on. Just a couple of housekeeping items before I turn the program over to our guest speakers. We are monitoring the Q&A feature and will leave time to answer your questions following each presentation. We also have a couple of students helping us answer the questions in the Q&A pod so we can cover more of your questions. Please feel free to submit a question at any point during the program and we will add it to the list. We also promise to wrap up by 8 p.m. Eastern so you all can get back to regular evening activities. Now it's my pleasure to introduce Doug Bowman, the Frank J. Maher Professor of Computer Science and Director of the Center for Human-Computer Interaction at Virginia Tech. He's also the principal investigator of the 3D Interaction Group, focusing on the topics of three-dimensional user interfaces, VR, AR user experience, and the benefits of immersion in virtual environments. Doug, the floor is all yours.
All right, thank you very much, Haley. Thanks to all of you for being here. It's a pleasure to be speaking with you tonight. I'm going to go ahead and share my slides here. Oop, and I did what I said I wasn't going to do. I forgot to hit the button to share the audio, so I'm going to do that again. Sorry, there's always technical difficulties. Well, while I'm getting that back up, let me just say a few words about what human-computer interaction and user experience are for those of you who might not be familiar with those terms. So human-computer interaction is really just about studying the interplay between people and computers, where computers are construed broadly. So not just PCs and laptops, but also phones and automobiles and microwaves and anything else that has digital interactive components. And my talk is specifically going to be about user experience, which is really a discipline or a profession that tries to understand users and their needs, that tries to design novel solutions using technology and other components, and that then tries to understand what the impact of those design choices are on people's experience. And it's not just productivity or performance, but we're also interested in things like emotional response and satisfaction and other more intangible stuff like that. So my talk is going to be about user experience in augmented reality. As Haley said, my lab deals with both virtual reality and augmented reality. And so I'm going to tell you about a little bit of the research that we do around the topic of everyday AR. So hopefully most of you have heard about AR in the past or have tried it yourself, maybe on your smartphone or maybe with a headset. But augmented reality is just the idea of overlaying or embedding virtual content, virtual objects, virtual information, virtual characters into your view of the real world. And so the most common way that people see this today is through smartphone or mobile AR, where you can look through your phone's camera and see virtual objects sitting on your desk or virtual furniture at life size in your living room. So my first point is that most of the AR applications that we know about and think about today could be considered special purpose. So applications in manufacturing, like in the upper left, or in architectural design, like in the upper right, maybe in maintenance, like in the bottom right, or navigation, like in the bottom left. And these are all great applications and really powerful ways to use AR, but they're special purpose in the sense that most people don't do most of these things. And even if you do them, you don't do them most of the time. It's really kind of a small part of your day if you do it at all. But what we're interested in this talk and in my group is everyday AR. So what do I mean by that? So everyday AR is a vision of a world where we have virtual displays that are available all the time and anywhere. And those displays contain information and applications that users may need anytime. So it's general purpose. Users are going to interact with those displays for all their general purpose computing needs, and those displays are registered in the three-dimensional physical world. I'll say more about that last one in a bit. But this term virtual displays, all I mean by that is that it could be a simulated physical display. So for example, a virtual monitor or a virtual smartphone. It can be an application or a window that's just floating in space or sitting on your desk perhaps, or it could be a 3D object or a scene. And a key point is that to realize this vision of everyday AR, we have to have all-day AR glasses. So in other words, glasses that people are willing to wear all day, that have all-day battery life, and that have good enough specs and performance that they can really be useful for all your general purpose computing needs. And so just to kind of say a few words about that, we do have AR glasses today, and they kind of look, for the most part, like the picture on the left. That's the Magic Leap 1 that those 4 people are wearing. And these glasses are kind of state of the art, but they're still bulky. They're not something that you would be able to wear all day. They only have a battery that lasts about an hour. They have a cable that goes down to a computing pack that's on your belt. And so they're not really everyday AR glasses. We don't have those today, but we do know that a lot of companies are working on them. So the picture on the right is a rendering that an Apple fan did of what Apple's AR glasses might look like. And this is just a rumor. This is not a real product, right? But this is the goal, is to have glasses that look and feel just like the sorts of eyeglasses that many of us wear all the time anyway. So those are coming. I don't know exactly when they're coming, but they will be coming. So once we have those all-day AR glasses, how can we do everyday computing? Well, we really want to address 2 scenarios. So the first scenario is working on your desktop or laptop computer, like the picture on the left. And the second scenario is using your smartphone, maybe while you're on the go, like the picture on the right. And so that leads to a couple of different metaphors for everyday AR. If you're thinking about kind of desktop or laptop computer use, the everyday AR version of that would be virtual desktop monitors. And so this is where we do focused work or productivity work, multitasking. And the thought is that AR virtual displays can replace all the physical displays that we use. Thinking about that second general purpose computing scenario of using your smartphone, you could also think of everyday AR as a wearable smartphone. So those glasses can, if they're always on, can give you access to all the apps that you have on your smartphone right now. And primarily, we would use them for information access or consumption, like checking your email or checking your calendar or the weather. We would want people to have very rapid access to that information anywhere, anytime. So that's kind of the big picture vision. So my question is, what are the user experience requirements for those sorts of systems? So let me talk about each metaphor in turn, because we've done work on both of them. So for AR virtual monitors, here's again kind of the vision. So this woman on the train or the airplane, she has a physical keyboard and maybe a physical mouse or trackpad, but all the displays are virtual. So she can have like a big multi-monitor type system, even though she's in these tight quarters and she's on the go. So if we're going to develop these AR virtual monitors, what do they need to do? Well, the first objective for user experience, I think, is just to do no harm. That is that these AR virtual monitors should provide basically the same level of performance, usability, and comfort as physical monitors. And this is tough because AR technology still has a lot of limitations in terms of field of view or resolution, or the virtual content being translucent, like you can see in this picture here. And other kinds of ergonomics and perception issues. Nevertheless, we have gone ahead and implemented this using state-of-the-art technology. So this is the HoloLens 2 from Microsoft. And here's my student. This is a real system, not a faked video. He's got 3 big virtual monitors around him. They're running actual Windows applications that he can interact with a regular mouse and keyboard. And he has no physical monitor whatsoever. So that's pretty cool. We also did a version of this that's a hybrid multi-mon. So he's got one physical monitor in the center because it still can provide higher resolution and readability. And then he's got some other windows that are on virtual monitors on the sides. So that was kind of our first prototype of this virtual monitors concept. And so like we do with all of our prototypes, we ran a little study to see how it performed. And I won't go through all the details of this, but we looked at physical monitors, virtual monitors, and this hybrid setup that I showed you in the last video. And the number one result is that everybody was able to complete all the tasks. We had them doing kind of multi-window, multitasking sort of regular office productivity tasks. So everybody completed all the tasks and they had no differences in accuracy. And so we would say that virtual monitors can now be used for real world work for at least for short periods of time using current technology. But if you look at the graph, you'll see that the virtual monitors led to slower performance, about 14% slower in our study. So we're still not quite there yet. My student Leo ran a follow-up study and he added one more condition, which was just a laptop condition. So it was a single physical monitor. They used virtual desktops instead of, so this is, when you kind of swipe across to another virtual desktop on your PC, but it appears on the same screen. And here he demonstrated that both the virtual monitors and the hybrid multi-mon improved productivity compared to the laptop. So the conclusion would be that even today, extending physical monitors with AR virtual monitors has measurable benefits. So that's promising. Of course, the technology still needs to get better, but it's promising. There's a second objective, which is we want to take advantage of flexibility and power of AR virtual monitors to enhance the user experience. So we don't just want to replicate the physical monitors that we have. So we've got lots of ideas about this, but here's one prototype that Leo has done, and we call it containers. And the idea is that instead of just replicating a couple of extra virtual monitors, we have these 6 slots or containers that are arranged around a physical monitor. And you can drag a window off the physical monitor and into one of these containers. It automatically snaps to the container and goes full screen. And then the cool thing is, if I fast forward just a little bit here, he gets all his windows in place. The cool thing is that if you press a key while you're looking at a particular monitor, it becomes larger so that you can see more information, and the other containers kind of move out of the way automatically. So this is the kind of flexibility and dynamic behavior you can get with virtual monitors that you could never get with physical monitors. So lots of other ideas like that are possible. Okay, let me move on to the kind of wearable smartphone idea. And so we call our approach for wearable smartphones GLANCEABLE AR. And that just means that information or apps are going to reside in the periphery on the sides of your view, and they're going to remain unobtrusive until they're needed. So like in this illustration here, these apps are kind of following along with the user as he walks. And when he wants to, for example, check his email, he knows that it's to the right, so he turns his head over there. The email app gets bigger so he can read what's on it, and then he can turn his head back and continue on his way. So we want information to be accessed at a glance in kind of a temporary way. So there's a lot of possible downsides to using AR as a wearable smartphone. And this video you should look up at some point if you haven't seen it, called Hyperreality, gets at a lot of them. But we want to avoid occlusion and information overload and distraction and clutter, and especially unwanted content like lots of ads intruding on your vision of the real world. So the first UX objective for GLANCEABLE AR is to be unobtrusive. And there's lots of ways you can do that. So this video is showing that this user is seated working on his computer, and he's got these kind of glanceable apps that are docked to the edges of the monitor. So they're not in anything, they're not in the way of anything important in the real world, and he can just glance at them when he needs them and then go back to his work. So that's one approach you can use. A second approach is to attach the content to your body, but have it normally reside outside the field of view. So in this example, we're walking down the hall, and if we're looking straight ahead, we don't see any virtual apps. But if you turn your head to one side, you'll see a virtual app off to the side. And then a third approach that we've looked at, and this is a VR simulation of it, is to just make the content mostly invisible until the user needs to access it. So this was an experiment we ran where the user needed to keep track of this little boy and respond every time he waved at you. And so we just keep the content very transparent. And if you need to answer a question from the content, you can click on it and then make it transparent again once you're done. So that's how we keep GLANCEABLE AR unobtrusive. The second objective is we want to enable rapid access to virtual content. And so this was some research we did that looking at what we called activation techniques. So in this prototype, the app just is a little circle that you could see there in the video. And when you look at the circle, both looking in that direction as well as looking at the depth of that circle, so focusing it with your eyes, only then does it expand into the app. So that little circle doesn't get in your way of doing important things like chopping your vegetables. But when you need to check the recipe, in this case, you just focus on that dot, the recipe expands, and then you can keep doing what you're doing. So we use eye trackers, obviously, to accomplish that. A third objective is to fit into authentic scenarios from everyday life. So we don't just want to make prototypes that work in the lab. We want to actually make this useful for real people in their real lives. And so this could be difficult because AR is unfamiliar to most people, especially head-worn AR. It's not necessarily socially acceptable to wear AR glasses everywhere. And people really like their smartphones and their smartwatches. So beating those is a difficult task. So here's a couple of things that we've done to address that. So this is similar to the previous prototype that you saw. This is a video that we put together of kind of different scenarios. So the first scenario is like a desktop computing scenario where the apps are docked to the monitor again. Here's an outdoor walking or exercise scenario where the apps kind of follow along with you out in the periphery, and maybe you can interact with them with gestures, for example. And then we also had, if I fast forward a little bit more. Oh, sorry, I don't have it in that version of the video. We also looked at like a cooking scenario, which I think you saw earlier. So we were thinking about how does this user experience work when you're doing real everyday tasks. The final objective I want to talk about is we think that these glanceable AR interfaces need to adapt automatically to the context of use. So it should know when you're sitting at your desktop computer and when you're cooking and when you're walking, and have a different interface or a different user experience, different information presentation based on that context. So here's a couple of illustrations, like this guy is cooking in the kitchen, and he's got the recipe. He's also got the baseball game going. And when he walks over to the fridge, only the recipe follows him, because that's the only information that's relevant to looking into the refrigerator for ingredients. And then the bottom illustration is about a social situation where this guy on the left is looking at some content, and when his colleague walks up to start a conversation, most of that content disappears, except when they start talking about the weather app reappears so that he can access it. So kind of understanding these contexts is difficult. It really requires artificial intelligence. But we've started to look at it. And so we've got a prototype here of kind of that conversational interface. So let me just play just a little bit of this video.
What do you usually do in your free time?
In my free time, I usually go hiking, and sometimes I play guitar and also play video games.
How many zone minutes
Yes,
of
that's all of the
exercise
good
have you had
stuff.
today?
I like all of those.
Thank you.
I personally go hiking a lot.
I have
so
23 zone minutes.
do you like hiking?
Yes, I do.
Nice.
All right, let me fast forward a little bit here. Okay. So that was the manual interface where he had to click on the content in order to answer the question that was asked of him. Now here's the intelligent interface that knows about the conversational context.
Like right now, I think I walked 3,000 steps so far, and it's only 9 a.m. How about you actually? Do you like walking? Like how many steps have you walked so far today?
Yeah, I like walking. And today I've walked 83 steps.
Oh, wow. That's not too bad.
So in that intelligent interface, the relevant app automatically appeared, and it also automatically moved out of the way so it didn't block the conversation partner's face. So that's the sort of thing that we want to enable with this intelligent glanceable AR. Okay, so I'm out of time, but I've talked about everyday AR here, and the idea is that we have these virtual displays that are available to us all the time, anywhere, and you can interact with them for all your general purpose computing needs. And so I talked about virtual monitors and also glanceable AR and some kind of user experience principles that we've developed so far, and there are many more to come, so that we can all enjoy this sort of everyday AR in the near future. So a bunch of students worked on this. as well as some students who have graduated, but especially I want to thank Leo and Feiyu and Chikiba. A lot of this talk was based on their work, and also my collaborators and funding agencies, obviously. So I'll end for now, and thanks for your attention.
Thank you, Doug. We do have some questions, and some of them are quite related, so I'm just going to lump them into one. Apologies for that, for the folks who asked them. But a lot of people are saying how AR is really cool, but can it be distracting? And you kind of covered some of the ways that, you know, taking the ads away when someone walks up to you or things like that. But what are some other things that you guys have seen in your research about how it can be distracting or how you're trying to take that distraction out of it?
Yeah, absolutely. We want to avoid distraction. That's part of being unobtrusive. And so, you know, I talked about things like moving the content out into your visual periphery so that it's not in front of you all the time. That's one way to avoid distraction. Another is to understand the context. So if the system knows that you're driving, it shouldn't display the same information to you, or maybe it shouldn't display any information to you, so you can focus on the driving tasks, because it's really dangerous to be distracted in that case. But one really interesting thing that Feiyu found in his study was that when we asked people to compare the GLANCEABLE AR prototype with their smartphones, they actually said that GLANCEABLE AR was less distracting, because it's actually much faster and easier to glance off to the side, read a piece of information, and then come back to what you're doing than it is to dig in your pocket or your purse, pull out your smartphone, unlock it, find the app, and then get the information that you want. So because of its speed and ease of use, it might actually be less distracting.
Very interesting. Alan had a good question here about people who have monovision with AR or VR, or, you know, have different vision between their different eyes or cataract surgery. Have you guys been able to see any differences with that in your research?
Yeah, that's a good question. And I mean, in general, accessibility is something we want to strive for. It's not something that we've gotten to yet in our research on AR virtual monitors or GLANCEABLE AR. I think it certainly could be an issue with some of our interfaces that are based on eye tracking. So for example, I had that one interface that requires you to kind of focus at the depth of the app in order to reveal the information in the app. And that might not be something that everybody can control with their eyes as well as everybody else. So the good news is we have lots of possible ways to interact with AR systems. So you can use eye tracking, you can use gesture, you can use voice, you can use a regular mouse and keyboard, or maybe even your smartphone. So we can provide different sorts of interfaces to different people with different abilities.
Great. And one more question before we move on. So there was someone in the chat that said that they're interested in AI and machine learning research. How do both aspects of the research, or sorry, what other projects or research are there happening now, and how are they combining the two topics of AI and machine learning?
Yeah, so it's really interesting how there's a convergence between kind of AR, VR, and AI ML. So between augmented reality, virtual reality, and artificial intelligence and machine learning. I think they both need each other. So in my lab, we are pretty much no longer developing just static augmented reality interfaces and applications. We really think that they need to be intelligent, like that conversation example I was giving you. And we've got a really cool project that we're just starting that's going to try to use augmented reality in the construction industry. And it's going to be really important there for the system to understand who I am if I'm wearing the system, what task I'm doing, where I am on the job site, what hazards might be around me. All of these things in order to display me the relevant information without blocking my vision or without making me unsafe. So we're really excited about using AI and machine learning alongside augmented reality in a lot of these applications.
Great, thank you. And we should have some more time to open up Q&A again at the end. So for those of you who haven't gotten your questions answered, Some patience, hopefully we'll get to them at the end. But without further ado, I'd like to introduce Sang-Won Lee, an assistant professor in the Department of Computer Science at Virginia Tech. His research aims to create interactive systems that facilitate empathy among users. His research vision of computer-mediated empathy comes from his background in computer music, thriving to bring the expressive, collaborative, and empathetic nature of music to computational systems. Sang, take it away.
All right, thank you, Ellie. Let me share my screen. Great. So yeah, well, thank you very much for coming to this event. This evening, I'm very honored to share this my research with you. So my research is about, I will title this talk as Towards Understanding Computer-Mediated Empathy, and then it might be new, but hopefully hopefully by the end of the talk, you will understand what I mean by that. So well, let's start with basic thing, like, human-computer interaction. This is what this the theme of 2 different talks are about. So there are a lot of researchers, including Dr. Bowman and I, like looking at this middle layer between HCI, middle layer between computational system and like user or people in general. So it could be any kind of computing devices such as laptop, phone, or like desktop computer. And then like computers are used in various like different contexts, right? So it's not just computing device where it calculates like a trajectory of falling star. It is like everyday thing. So you use it for entertainment, you use it for work, like study, and a lot of different things. And one particular domain that I was interested in my research is that social interactivity. So like imagine like, well, like maybe ask yourself, how do you communicate with your friends and loved ones? So it's nearly impossible to think a way to connect with people without using computer, like even when you let's say have to drive to your family like in a different state or something, like you have to use navigation, right? So and then like today, like using social media or Zoom, like you go to virtual school, email, FaceTime. So there's like a really lot of use of computer in connecting with people. So in a high level, it looks more like this, like it maybe like like the way that that human interact with each computing devices, we could see it as an HCI problem. In a broader perspective, there are a lot of things are happening because like our social interaction is mediated by computers today. So that's kind of the research area that I'm in, which is often called CSCW. It stands for Computer Supported Cooperative Work because it originated from the context of work, but it's largely about social computing. So the particular research topic that I'm interested in is empathy. And empathy is a very interesting topic because, like, let's say there's a person who feels certain emotion, then they're thinking about it, you don't really know what's going on. Let's say you want to empathize with this person, and then that's going to be really challenging, even without technology, right? So how do we like help people empathize with others? That's a really important problem, I believe, because a lot of the problem that we face in society today could be framed or it could be understood as people having trouble in empathizing with other people. Here's a few examples. Let's say like a product designer or developer not being able to understand some of the challenges that like certain users will have. Or maybe expert user not being able to understand the novice users like challenges. Or maybe like a education system or instructor having challenges understanding like, people from underrepresented group in their education system. So like if you can help people empathize with other people, I think we can solve a lot of societal problem here. So that's kind of the research question that I'm trying to tackle. So my overarching theme of research question is that, can we leverage computers to facilitate empathy among people? If so, how? So today, Well, so this is like, I think this is a very challenging problem to solve in one shot. So how I approach this problem is to break down into more of a smaller problem so that I can go towards this computer mediated empathy. So this is kind of the framework that I use for my own, like to tackle smaller problems. So I read a lot of papers from different disciplines, from psychology, social science, and nursing, neuroscience, and then researchers have said that for empathizer, you need to have these 4 components. First of all, you have to share perspective, like you need to be able to see the world from other people's perspective so that they know, you know how they would feel. And also you have to stay non-judgmental when you understand, rather than trying to judgment or criticize. You have to understand as is. And then you have to be able to recognize emotions, such as being able to read facial expression, or maybe being able to sense agitation from people's voice, so that you can feel how you can know how people feel. And then to close the loop, you have to communicate back how you understand other people. But also we could do something for target as well with technology. I think one thing that we could do is to help them express themselves, because you should be willing to effectively express your emotion and what's going on, so that you can share the context that you're in with other people, so that you could be understood. And then we should create a safe and judgment-free environment. Like you can imagine, today's online environment is pretty dangerous and risky, and it's not really good for vulnerable people, right? Lastly, I try to create tools for self-reflection, because self-reflection is kind of like empathizing with yourself, but also studies has found that if you're good at self-reflection, you're going to be good at empathizing with other people as well. So this is a lot of the topics that I would like to pursue in for next 10 years, but I'm kind of starting. The one thing that I forgot to mention is that foundation of all these problems is better understand computer mediated communication, so we can understand better about how we could facilitate empathy. So today I'm going to share 2 projects that I have worked on about perspective sharing. I have some other projects that are relevant to other components, but for the sake of time, I'm going to show 2 different projects. First one is called VR Viewfinder, and the other one is called Other Two. So let's go into the first one, a VR Viewfinder. So the core idea of empathy is perspective sharing, and then the idea is that, and then when we talk about empathy, we say that you have to think from, you have to put yourself in someone else's shoes, so that you can see how they view the world. So that's that could mean many different things, but sometimes it could mean literally visual perspective. Sometimes we don't get to see what other people see. So here's a fun little internet meme that I found, where parents bought this a stuffed animal mobile, but then what the baby sees is completely different thing that they wouldn't have expected. So what is the case where I cannot see what you can see? So VR is a good example where obviously VR headset user is experiencing something, but probably bystanders who are not wearing VR headset cannot understand what's going on. So this Time magazine cover a few years back, you can imagine that would created a lot of internet memes, because this looks funny, but maybe if I could understand what was going on inside VR, I could have understand why they're doing that. So this is maybe, I don't know how many people you have used VR headset, but you might have seen went to a gallery or art museum or exhibition where people are experiencing the VR headset. As a bystander, you don't know what's going on. So how do we solve this problem? One solution that I can think of is something like this. Maybe we can have a bunch of VR headset and then distribute the VR headset to everyone, and then you'll be able to see what other people are experiencing. So, which is an interesting approach. But I don't know what's going on, but there's something dystopian about this picture, something uncomfortable about this picture. And then I don't know if you feel the same way. So you might guess that this is not an ideal solution for various practical reasons, but I know one of the reasons because VR headset is not built for everyone. So let's say like the picture on the top left here, like almost like a three-year-old kid is wearing this VR headset, but it's not. It's only happening in stock image. It's not happening in real world because manufacturer does not recommend children to use VR headset. But also other users, like there are a lot of different reasons why other users will not be willing to wear VR headset. Maybe because of their hairstyle. Maybe like some people wear makeup and they will remove it. And then on the top right, there's like a article about Facebook employee had to shave his head to make wearing VR headset easier. And then you can guess that not everyone is willing to do that. So it's not for everyone, it's not inclusive enough. So like what we suggested here is that, hey, why don't we use a tablet, because it's much more like widely used by everyone, and it doesn't have to like you don't have to wear this headset. So we suggested a system called VR Viewfinder, where you can use this tablet as a window to see virtual world through. So like without seeing what's going on inside, you would have not understood like what this person is doing. But with this tablet device, you can see that, hey, this person is playing this sort of VR-based game and he's fighting with this dragon, which is really cool. So yeah, this is what we suggested. And obviously this is a very collaborative work with my colleagues and students from various disciplines, which work towards like having inclusive and social virtual experience using motion track tablet. So I'm probably gonna skip all the scientific details or like result, but I wanted to show this video that I took randomly during our break. Like, so this is my son, Jason, like he was 7-year-old at the time, but he's using this tablet to play this VR-based game, which is basically I don't know, find the treasure and then like pop the balloon and so forth. But personally, I would have not feel like comfortable to have him wear a VR headset, but I feel completely fine like playing this VR game with this tablet, because that's kind of like that's kind of the technology that he uses every day, like at home anyway. In this other demo, he's actually playing like interactive game with the VR headset user. So VR headset user is like playing a Pictionary game. So he's drawing sort of like a 3D object, and Jason is supposed to guess what he's drawing. And then you can see he's already distracted with some other stuff that are going on in the VR world. So yeah, you can see that this is a much more inclusive way to experience VR. And what we are planning to do is actually develop a content for Science Museum, and then we're actually collaborating with a lot of different people in Virginia Tech, as well as folks in Science Museum of Western Virginia in Roanoke, so that we can deploy the system in the museum. And we're actually developing content where family members can experience this virtual solar system. And I think Science Museum is a great place to test this idea, because you do not know who's coming, right? There could be a lot of children who are coming with family members and parents, and then there's like the wide age range of the visitors. So this is the kind of project that we're working on at the moment. Another project that I'm going to show you today is other two, which could be interesting to you, because like a lot of people use YouTube. So essentially what, so let me go back and explain a little bit more. So VR Viewfinder was about, hey, perspective sharing sometimes has to be literally, implemented so that I can see what people are seeing. But like when we talk about perspective sharing, it's not just what I see, but how I see the world, and then the opinions that I have and so forth. So that's kind of the problem that I try to address in this particular project. And it is about filter bubble. So I don't know if you're familiar with the term called filter bubble. So filter bubble is, this person said, is your own personal universe of information that's been generated by algorithms that are trying to guess what you're interested in. And then you can imagine it's challenging to share perspective when we are trapped in a filter bubble. So filter bubble you can imagine something like, news feed that you would see in Facebook, where it will show maybe one-sided story in the political events, or like video that you would like to watch. So whenever I log into Facebook, it always try to show me a video of of an animal being rescued because I watch it, and then algorithm know that I watch it for a long time if they show me that kinds of video. So again, I'm using my son's example. So I used his Google account to log into YouTube and what it looks like. And then this is the filter bubble that he's trapped in. And apparently you might have noticed that this is very different from what you would have expected in your YouTube. So this recommended video is highly customized for this particular person and based on what they watched in the past. Why do they do that? Because their goal is very clear. Their goal of the algorithm is to keep you engaged. They don't care about truth. They don't care about whether the Earth is flat or not. What they care about is make you engaged with the platform so that they can use it. Users are going to watch the video longer because that's how they make money. So how do we burst this filter bubble? So we created this, not we, like actually the Bowman PhD students who are in the room, actually, who could answer your question if you have any, created this Chrome plugin called OtherTube, which is kind of like the opposite of YouTube, other people's tube. Tube means TV in old term. So what it does is like it's going to collect your recommended video and then swap it with other people. I will not swap, like, you can see other people's video, recommended video, and then your in exchange of your recommended video. So the overall idea is that, hey, maybe the best way to recognize your filter bubble is to be in someone else's filter bubble. Because like now you go into someone else's bubble and you could realize that how different things are, and then like maybe find like a content that you have never experienced before. So the goal of the project was to help people recognize their filter bubble and reflect. So this is what the system looked like. So this is actually a Chrome plugin which is going to augment your YouTube webpage. So the dark part on the top that you see is recommended video to a stranger that I do not know. There on the bottom, you can still see your recommended video, but you can see how different those two are. Like obviously this person is into rock from 80s, and then the person on the top, stranger, is obviously into Indian culture. And then you can even see, sort of like see who they are. So here we ask people to write a very simple profile, anonymous profile. So it looks like she is white female in North Carolina, and she's in 50-something. And like she could write a very short bio, like love traveling, food, and my family. And obviously, like she probably do yoga, and then maybe she's using these Indian music to meditate, maybe, which is kind of surprising to see, right? So not just because how it's different from your feed, but also because, hey, I didn't expect that someone from North Carolina will be into Indian culture. So findings, we did a study, and then we asked users to use this system for I think about 2 weeks, and then realized, and then what we found out is that actually OtherTube helped people recognize the filter bubble. So you can see that, hey, like I learned how unique and distinct my taste and preferences are. And then some people were more specific about their preference. And another cool thing that we found is that OtherTube actually facilitate understanding. So here one participant said, I found it very cool that someone in their 40s were still watching Olivia Rodrigo. Makes me feel better about aging. So maybe it could help like bridge the generational gap, so that I could understand, hey, maybe they will feel that, hey, we're not too different from each other. One striking thing that we found is that actually being in another person's filter bubble is cool, because it can help you discover new content you did not know that there are available in YouTube. So one person said, hey, like, this, like I don't normally listen to classical music, but like seeing this recommended video is a welcoming change. And then the other person said, this tool forced me out of my comfort zone, so that I could actually think before I decide what to see and what to choose to watch. So these are two examples that I wanted to share with you regarding like computer-mediated empathy. A few takeaways I wanted to convey today is that there are many computer science researchers are studying how we are socially connected through computers. And in my example, you might have seen that you could notice that technology could be used to facilitate empathy among people. And like, you can support and participate in HCI and CSCW research if you have, find any opportunity. So if that in mind, I could take any questions.
Great, thank you. I love how you include your son in your research.
Yeah, it's a bad way. It's a child abuse. Don't please report.
So a question that we have here for you is, with a growing concern of privacy and that associated with further integration of technologies into our lives, what do you think is the right way forward, and how do you address those concerns?
Is it piracy or
Privacy.
privacy? Yeah, that's a very interesting concept, because I mean, very important, like, more and more our data is shared with these big companies, and they are fine-tuning their algorithm to provide content that are almost like, make us addicted to these content. So it's a very important topic in NCI, and a lot of researchers are working on to solve this problem, concerns that we have in privacy. And in relation to my research in particular, is that maybe you haven't thought about it, but empathy is kind of the opposite of privacy. So if you want to feel understood by other people, let's say your significant other got mad because of something that happened in the morning, and if they don't tell you what happened in the morning, there's no way for me to understand why they feel like how they feel right now. So they have to be willing to open up and share information in order to help other people empathize with you. So that's like there's a tension between computer-mediated empathy, because like now we have to give up like some information so that other people can understand you better. So yeah, I mean, this is like a very active research topic in HCI. And then one thing that I meant, which is what I mentioned in my talk shortly, was that maybe we should create online environment, and we should make our environment more safer and privacy preserving, so that people will know that what I share online will not be used in in a harmful way by other company. And then like raising awareness for lay user, because I don't know if you have seen all these lengthy documents that you have to click I agree when you log into some social media, which nobody reads, but making it approachable so that anybody could understand kind of the risk or what they're getting into is a really important topic that are being studied by many researchers, not actually by me at the moment, but HCI researchers are working on it.
Great, thank you. Another question before we open it up to both you and Doug. With OtherTube, are you able to share your bubble with specific people, or is it at random?
It's completely random. So in a sense, I think that's an interesting way, because well, I mean, if we start to connect people with someone who shares common interests with you, or connect people with someone who share like common feature with you? Like let's say maybe it's like same kind of age range, more maybe the same like sort of location, like maybe educational background wise. So even like maybe that could help you find someone who watched something similar to you. But we decided to go the other way, where we're gonna match like a complete random person and on YouTube, so that you can kind of experience like more like a diverse filter bubble, if that makes sense.
Yeah, that does make sense. Thank you. All right, Doug, if you want to turn your camera back on, we'll have both of you for these next few questions. They're a little bit more generic, so both of you feel free to hop in and answer. The first one is, how can we extend interfaces capabilities to incorporate muscle memory and interaction with the world space that's not within the headset awareness?
Yeah, I can take a stab at that. I mean, I think one of the great things about VR and AR systems is that you can use your whole body for interaction. So rather than just one finger on a mouse or the things that you can do with a keyboard, you do have the capability of what we call embodied interaction. But I think what the question may be referring to is that a lot of current VR headsets only allow you to interact with your hands if your hands are right here in front of you, in view of the cameras. And so that's pretty awkward, right? I don't always want to be interacting way up here. My arms are going to get tired pretty quickly. I'd love to be able to like remember that a virtual object is over there somewhere and just swipe at it without looking at it. And so I think the real answer to being able to do that is that we need the headsets actually to expand the coverage of the cameras that are being used to track your hands, because people do this all the time in the real world. You interact with stuff without looking at it, and you interact with your hands and arms in a comfortable position. So I think some headsets are starting to do that. They certainly have cameras that have fields of view that are way beyond the visual field of view, and so that's becoming possible. But the technology still has to catch up a little bit.
Tang, any thoughts on that one?
Actually, I wasn't thinking about like it was more of a like question for Doug, I suppose, like with his expertise on VR headset. So I don't have anything to add.
Okay, that's fine. The next question is, it's often cited that motion to photon latency should be less than 20 milliseconds. What's your opinion of that recommendation in everyday AR scenarios?
Yeah. So first of all, hi John. I'm glad that you're here. Hadn't talked to you in a while. So thanks for the question. I mean, when I first read that question, my thought was, the stuff that we're doing in everyday AR, excuse me, everyday AR is pretty simple. It's just little apps or windows or whatever. And so if there's some latency and things move around a bit, maybe I don't care as much. But as I thought about it more, I think if we're going to do things like, dock applications to your visual periphery, or dock them to your desktop monitor or whatever, if every time I move my head, I see those things bouncing around, I think the distraction is going to be pretty significant. And so for everyday AR to really feel like something that I want to do all day, and that's the other thing, right, is that this is long-term use. It's not a 10-minute VR session. It's like all day visibility of these applications. I think the requirements for latency are probably still pretty high, maybe even greater than they are for some short-term use VR applications.
Thank you. The next question we have is, can AR technology help in marketing? I love this question, but I'm a little biased over here.
Sang, do you want to start with that one?
Oh yeah, I think that's like a lot of potential of AR technology in marketing, like for sure. Like but I mean, in Dr. Bowman's talk, I don't know if you remember these lot of ads are happening in front of you. Sort of like a pessimistic version of it, but the fact, like, you can imagine like companies are already doing that, like and I don't know if you've seen like Amazon, where you can go there and then see, like, place sort of like a furniture in your room using phone. I could imagine like a sort of like a mirror that you can like try your new clothes without even actually trying it, like, or without even visiting the actual store. So I think like AR has a lot of potential there for sure. Obviously, like there could be some negative implication of using such technology in marketing. So that's kind of a topic that researchers should study, and which are, I think this is actively being researched at the moment.
Yeah, I would just add, just to reinforce that last point. I mean, I know that a lot of the digital economy is driven by advertising. And that's why a lot of things are free for us, like all Google services are free for us because of that. But if it's something that I'm going to be wearing on my face all day, and I can't get away from the ads at all, that's going to be problematic. So I think we've got to figure out ways to still allow companies to have a valid business model and make money, and at the same time allow me to choose when I want to see ads and what ads I want to see in a better way than what we have right now on social media, if we're doing it in AR.
All right, we've got time for one more quick question. How would you address cybersecurity challenges with more computer-intensive and web-focused AR technologies?
Right. So I'm not a security researcher, but I thought about the privacy angle with AR quite a bit. I haven't thought as much about the security angle, but there's going to be a lot of data on my AR glasses that is pretty personal to me. And it's not just, my usernames and passwords, but it's also stuff about like how my eyes move, what my iris looks like, which is something that could potentially be used like a digital fingerprint. We had a talk about that a couple of weeks ago, actually, in the department. The way that my body moves. Maybe you can even, guess some of my measurements or whatever by data that you get from an AR or VR headset. So keeping that data secure, and not letting it off the headset in an unencrypted way. All of that stuff is there are some security risks for individual users for sure. And I think we're going to have to, just like I was talking about how we have to collaborate with AI ML researchers to do intelligent AR, I think we have to collaborate with privacy and security researchers as well.
Yeah, I don't have anything to add to that, actually. That security is also very important topics that with these emerging technologies, because we have seen, like, maybe researchers have been looking at this, like, traditional sense of computing, like where they think about like password, fingerprint, but with this new emerging technology, there are other ways to leak data, personal data. So that's probably an emerging topic that needs to be studied.
Well, we are just about out of time. I just want to thank Doug and Sang for sharing your insight with other great Hokies as well as prospective Hokies this evening.